Solution of the Schrodinger's equation. The time dependent Schrodinger equation is given by minus h cut square by 2m del square plus v bracket psi is equal to iota h cat del psi by del t, equation number 1. This equation is partial differential equation in 4 variables. The 3 position coordinate of the particle x, y and z, and the fourth variable is time t. In the case where the potential energy V is independent of time and dependent on position only, then time and position coordinate are separate in equation 1, so that psi may be expressed in the form psi is equal to y x y z u function of t, equation 2, where phi x y z is independent of time t, while u function of t is independent of position x y z. Now from equation 2 and 1 we get minus h cut square by 2m del square plus v x y z bracket phi x y z. Here ut is a function of time, so ut will be constant for del square and vxyz, so it will come outside the operator. Is equal to minus iota h cut del by del t phi xyz ut. Here phi xyz is a function of position and del by del t is operator corresponding time t, so phi xyz will come out and consider as a constant. Dividing throughout by phi xyz ut, we get 1 by phi xyz bracket minus h kit square by 2m del square plus vxyz phi xyz is equal to iota h cut 1 upon ut del ut over del t. Equation 3. In equation 3, left hand side is independent of time t, while right hand side is independent of position xyz. So if above equation is to be satisfied, each side of equation 3 will be equal to constant E say. So we have 1 by phi xyz bracket minus h cut square by 2m del square plus vxyz bracket close phi xyz is equal to E, or del square phi plus 2m over h cut square E minus v phi is equal to 0. Equation number 4. Here we have multiplied the whole equation 2m by h cut square and multiply by phi xyz, and we got equation 4. And iota h cut 1 upon mu t del mu t over del t is equal to E. Equation 5. The solution of equation 5 may be written as ut is equal to e raised to power e t over iota h cut is equal to e raised to power minus iota e t over h cut. Question number 6. If we compare this equation with that for a plane wave, E must have the dimensions of energy Thus we can say that the E designate the energy of the particle which is described by this solution of Schrodinger equation with this value of ut equation 2 becomes psi is equal to phi x y z e raised to power minus iota at by h cut. Equation 7 from theory of linear differential equation. It is known that the physically accepted most general solution of equation first can be written as linear superposition of the form 7. Consequently, most general solution psi of Schrodinger's equation for time independent potential energy can be written as psi is equal to a1 phi 1 xyz e raised to power iota e1 t by h cut plus a2 phi 2 function of xyz e raised to power iota e2 t by h cut plus an phi n function of xyz e raised to power iota en t by h cut plus and so on. Psi is equal to summation n is equal to 1 to infinite an phi n function of x y z e raised to power iota en t by h cut. Equation number 8. Now the another topic is stationary state solution. in a particular stat if the probability distribution psi star is independent of time, then the state of the system is said to be stationary state. Let us consider the probability distribution psi star for a system in the state represented by wave function psi x y z t is equal to summation n is equal to 1 to infinite an phi n function of xyz e raised to power minus iota en t by h cut. Question number 1. Its conjugate is represented by psi star xyz t is equal to summation m is equal to 1 to infinite am star phi m star function of xyz e raised to power iota en t by h cut. So that psi star is equal to bracket n is equal to 1 to infinite an phi n xyz e raised to power minus iota en t by h cut bracket close bracket open summation m is equal to 1 to infinite am star phi m star function of xyz e raised to power iota en emt by h cut is equal to summation an star phi n xyz phi m star xyz plus summation all over m summation all over n prime an am star phi m xyz phi n star phi m star xyz e raised to power iota em minus en t by h cut where the prime on the double summation indicates that the terms with m is equal to n are excluded. Clearly, time enters in the probability function psi star. Hence, psi expressed in equation 1 is not a stationary state solution. Psi star will be independent of time t only if ans are 0 for all values except for one value of en. In such case, the wave function will contain only a single term and will be represented by psi n is equal to function of xyz, t is equal to phi n function of xyz, e raised to power minus iota e n t by h cut. Equation 2. The function phi n xyz being a particular solution of time independent Schrodinger equation. The solution represented by equation 2 is stationary state since psi star is equal to phi n star, which is independent of time. Thank you for watching the video.